This is the homework help video for worksheet H8-2. The directions state use the bold regions of the number line to represent the regions where outputs on the graph are positive. Use open circles to represent roots, x-intercepts. Find the equations of the graphs of the following functions. So letter A on number 7. If we take this and we sketch where our graph would be, remember the bolded regions, which are here and here, are where our graph is above the x-axis. That's where they're positive. So if I was kind of sketching it out, right, I know I'm on the x-axis, it's going to come up, right, and it would be going down there. And since beside each of these it's not bolded, that means this would go down here, and it would go down here, it would come up, hit here, it would be above it, and then it would come back and be below it. So if we're looking for what is the equation, first of all, we notice that it's got a negative orientation. So we'll start out with y equals a negative. And then we'll look at our roots. Each of our roots here appears to be a single root. So at -5, we'd have a factor of x plus 5. At -2, we'd have a factor of x plus 2. At +1, we'd have a factor of x minus 1. And then at +5, we'd have a factor of x minus 5. Let's just put it all together. So we have a negative quantity of x plus 5 times x plus 2 times x minus 1 times x minus 5. Let's move on to letter B. So as you trace it, just think about it again. Make sure that it's at the x-axis at the circles. So in this one, we'll come up, we'll be above it. And then we're going to come back down to 0. But remember, it's bolded on the other side. So it has to bounce and come back up. And then curve and go back down through. And then don't forget about this other little piece. Right, so as we come back down, we have to curve and come back up and hit it and then come back down. It's usually a few people that overlook that last root at 4. So as we take this and we put it together, we'll see again, this one also has a negative orientation. So we've got y is equal to a negative. And then let's see what we have. So we have a single root at -5, so that'd be an x plus 5. We have a double root at 0, so that would be an x squared. We have a single root at x minus 2, or that's what our factor would be. And then we have an x minus 4 squared. Okay, so we'll go ahead and put this all together. So we say negative x squared times x plus 5 times an x minus 2 times an x minus 4 squared. Okay, now a good way to double check here, notice that this one's going to have an even degree because its end behaviors are down, down. So we should have, in terms of degrees, this would be 1, this would be 2, this would be 1, and this would be 2. Add those roots together, 2, 3, 4, 5, 6. You'll see that that matches up. Now, is this the only equation we could have? No, because remember, when it bounces, this could be a, an x minus 4 squared. It could be an x minus 4 to the 4th, to 6th. So this is like the minimum equation that we could have. Let's look at C. Okay, with C, notice we got the arrow on the end here, right? So that's meaning that it's going to be going down forever to the left, or up forever to the left, I should say, right? Because it's bolded. So we know that we're starting up here. We're going to hit here. We're going to be underneath. We have to hit the x-axis here again, and we need to come back down. And then we need to go through and come back up on the other side. So our equation on this one, we know positive orientation, so y equals, and this would be an x plus 1 as a factor. This would be an x minus 2 squared, and then this would be an x minus 4. Let's put it all together. We have x plus 1 times the quantity of x minus 2 squared times x minus 4. Should be even. We've got 1, 2, 3, 4. Yep, looks good. Let's move on to D. For D, same thing. If you've been working along with me this whole time, maybe you do this one on your own and then check it. So it looks like we're going to be starting from above. We go down, we're underneath, we come up, we're above, now we're back down, and it looks like we're going down to the right at the end. So again, negative orientation, y equals a negative. And then it looks like we have 3 single roots. We've got an x plus 2 as a factor, we have an x as a factor, and we have an x minus 2 as a factor. I like to put my x's first because they're monomials, and then I'll put everything else after. So there are the answers for problem 7, A, B, C, and D from worksheet H8-2.